Okay, let's get right into it. If you're building an AI voice agent, the speech-to-text provider you pick is, without a doubt, one of the most critical decisions you're going to make. I mean, get it right, and you've basically set a super high ceiling for how good your agent can be. But get it wrong, oh man, you are staring down the barrel of a painful, costly migration just a few months from now. We're talking about a decision that can literally turn into a six-figure mistake. And trust me, one team learned that lesson the hard way. So check out this quote from a senior ML engineer. It's, well, it's a painful story we see all the time. They got sucked in by the promise of a free open source model, but then reality hit. They found out about all the massive hidden costs, the engineering hours, the infrastructure, the performance problems. It's a $140,000 mistake that really shows you just how high the stakes are here. So that brings us to the big question for any engineering team, right? How do you actually get this right from day one and avoid falling into that same expensive trap? Well, I'll tell you this. The answer is not in the marketing brochures. It's in the data, the real-world production data. All right, first things first, let's bust a huge myth. You know that standard word error rate, or WER, that you see splashed all over the marketing materials? For a real voice agent, it's pretty much useless for predicting how it'll actually perform. And the reason is simple. Those numbers, they come from clean, perfect, studio-quality audio, which is nothing, and I mean nothing, like what your agent is going to hear on a real phone call. This right here, this shows the critical gap. On clean audio, yeah, most of the top models look fantastic, posting an impressive 5% error rate. But the second you put them on real phone audio, with all the network compression, the background noise, that error rate often doubles. It shoots up to 10, 15, sometimes even 18%. And that is the gap where voice agents completely break and conversations just fail. So if that clean audio WER isn't the whole story, what is? Well, for a production voice agent, it really boils down to three things. Number one, streaming latency. How fast can the agent actually start responding? Number two, the hallucination rate. How often does the model just invent words that were never even said? And number three, the total cost of ownership, which, trust me, is way more than just the API fee. Okay, so with that framework in mind, let's break down the three main players you're probably looking at today. Deepgram, AssemblyAI, and of course, a self-hosted version of OpenAI's Whisper. Each one has a really distinct profile, and picking the right one totally depends on what you're prioritizing. First up is Deepgram. Now, these guys are a speech AI-first company, and you can tell their whole solution is purpose-built for one thing: speed. With their Flux technology, they offer native end-of-turn detection right out of the box. This means your agent knows the exact moment a user has stopped talking, so it can jump in and respond instantly. No more awkward pauses, no more accidentally interrupting. It just simplifies your whole stack and shaves off those crucial milliseconds of latency. If you want real-time conversational flow, Deepgram is your speed demon. Next, let's talk about AssemblyAI. Their whole value prop is built around accuracy and reliability. They've got the lowest hallucination rate on the market, about 30% lower than Whisper. Now, why does that matter? It's absolutely critical for agents that have to trigger actions or call tools. Think about it. If your agent needs to know the difference between cancel my order and confirm my order, a single hallucinated word is a catastrophe. AssemblyAI is built to minimize that exact risk. And finally, we have Whisper. Look, it's a powerful and super flexible open source model, no doubt about it. But that power definitely comes at a cost. The biggest catch? Latency. And here's why. Whisper's architecture was originally designed to transcribe audio files after they're finished, with maximum accuracy. It wasn't built for real-time streaming conversation. It processes audio in these big chunks, which naturally introduces delays. A typical self-hosted setup can have a delay of 1 to 5 seconds. That's a complete non-starter for any voice agent that needs to feel even remotely responsive. Of course, the appeal of Whisper starts right here. A price tag of $0 per minute is, well, it's incredibly tempting, but this right here is where that $140,000 mistake we talked about gets made. Because free is not free, not even close. You're paying for it with expensive GPU compute hours. You're paying for it with the salaries of the DevOps engineers you need to babysit and scale the whole thing. And you're paying for it every single time the model needs an update or something breaks and needs to be patched in the middle of the night. Let's put some real numbers on that. For a startup doing about 100,000 minutes of audio a month, the fully loaded cost of a self-hosted Whisper instance, once you factor in engineering overhead, is somewhere between $5,000 and $7,000 a month. All of a sudden, those cloud APIs start looking a lot more competitive, don't they? So, here's the deal. We have to compare these providers on the metrics that actually matter to the user experience. Let's get to the data and see how they really stack up on latency and hallucinations, two of the biggest things that will kill your agent's performance. This table does a fantastic job of laying out the trade-offs. First, look at word error rate on real phone audio. You can see Deepgram and AssemblyAI have a slight edge over a standard Whisper setup, so you're starting from a more accurate baseline. Now, P50 latency, that's the median response time, the key to a conversation feeling natural. And wow, the cloud providers are an order of magnitude faster. But then look at the hallucination rate. This is what stops your agent from just making things up. AssemblyAI is the clear winner here with the lowest rate, which is how you build user trust. And finally, native turn detection. That's a feature that only the specialized cloud guys offer right out of the box.
And this latency difference, it's just massive. I mean, look at this. AssemblyAI and Deepgram, they're firing back responses in under 300 milliseconds. To a human, that feels instantaneous. It's a real conversation. But Whisper, on the other hand, can take up to 5,000 milliseconds. That is a full 5-second awkward silence where your user is literally thinking, hello? Did the call drop? It completely shatters the illusion of talking to something intelligent.
And hey, this isn't just theory. Here's a real-world case study from a healthcare AI startup. They totally hit a wall with their self-hosted Whisper instance and decided to migrate to Deepgram. The results were, well, they were dramatic. An 83% reduction in latency and a 77% drop in their total monthly cost. So what did that actually mean for their business? Well, that faster latency wasn't just a tech win. It led to a 21-point jump in their containment rate, which means way more calls were handled by the AI without needing a human. Fewer hallucinations meant a 65% drop in wrong tool calls, preventing super costly errors in a sensitive healthcare environment. And the bottom line? They saved thousands of dollars every month, and they freed up an entire full-time engineer to work on the actual product instead of just managing infrastructure. Okay, so we've seen the problem, we've gone through the contenders, and we've looked at the hard data. Now let's pull it all together into a clear, actionable framework you can use to make the right call for your project. Here's the bottom line. If your number one top priority is speed, a really natural conversational flow for a high-volume phone agent, Deepgram is going to be your best bet. If your agent is triggering critical actions where you absolutely cannot tolerate mistakes, like a fintech agent confirming a big transaction, then AssemblyAI's industry-leading low hallucination rate isn't just nice to have, it's a requirement. And if you have strict on-prem data requirements, or you have a dedicated ML team ready to really get their hands dirty and optimize the heck out of it, then Whisper can become a viable option. You know, the choice of your speech-to-text provider really comes down to this one question. Is your main bottleneck speed, accuracy, or cost? The very first step to building a voice agent that actually works is to figure out and then solve that core problem. Understanding these trade-offs, that's the whole key.